Exponential growth and decay, we have a formula to help us model application problems. So you should be familiar with this formula right here. Okay, A in light green, that stands for the initial amount or the starting amount of your application problem. And then we have 1 plus R if it's growth and 1 minus R if it's decay. And then T is our variable, and that stands for time. So very important, R is your rate, so it needs to be a decimal. Most word problems will give it to you in a percent. Okay, so just make sure you're converting R to a decimal. And then 1 plus R, that actually has a special name called the growth factor. And then 1 minus R is called the decay factor. So those are important vocab words that will come up. So let's look at our first example. It says a guitar was purchased in the year 2000 for $12,000 and it will increase by 14% per year. So notice it says increase. That means we're dealing with growth. So I'm going to use the formula 1 plus R because it's growth. Okay, and then we're going to use our graph to find when the guitar will be $60,000. So if you don't have a graphing calculator at home, you're going to want to use Desmos, which is okay because Desmos is actually a little bit more user-friendly, especially for problems like this. So let's go ahead and plug into our formula. So A, the initial amount, that is going to be how much the guitar originally cost, which is $12,000. So A of T equals 12,000, and then 1 plus R. Well, our rate says 14% per year. We want to convert 14% into a decimal. So there's different ways to do this. You can move your decimal place 2 times, so it's going to be 0.14, or you can do 14 over 100. Either way, it's going to give you 0.14. So here's our equation, and that's what we're going to put either into Desmos or into y equals for our graphing calculator. So go ahead and plug that in, and then let's look at the table. If you're on Desmos, you're going to have to press the gear, the setting button, and hit table. And we want to find when is the value of the guitar 60,000. So we're actually looking at the y values. So if we scroll down on our table, we notice at 12 years, 12 years, the value of the guitar is about 57,000. And then at 13 years, it is 65,000. So that was a big jump. So it's going to be between 12 and 13 years. So Desmos, it's much easier to find exactly how many years. Maybe it's about 12.25 years. But for this problem, the way we're going to answer it is we're going to say it's between 12 and 13 years. So if it started at year 2000, we're going to say between 2012 and 2013. The guitar will be $60,000. All right, let's do another example. Here we have a truck that's bought for $28,000 and now it's decreasing. So decreasing, that tells us that we are using decay. So we're going to use 1 minus R to the T. We want to write the function and then predict when it will fall below $5,000. Okay, so let's go ahead and plug in. Our initial amount of the truck is 28,000. So our lowercase a is going to be 28,000. 1 minus R, so 9.5. Remember, convert that to a decimal because it's right now a percent. We can move our decimal place 2 times. Or you can do 9.5 divided by 100, so 0.095 to the T. So let's go ahead and type that in, either to our calculator and into Desmos, pull up the table, and we're looking to where it falls to $5,000. So we can't find it exact, unless you're on Desmos, you can. But using a graphing calculator, we notice after 17 years, the value of the truck is 5,100. And then 18 years, it is 4,600. So I'm rounding these numbers. So we're going to say between 17 and 18 years is going to be our answer to the second part of this. So between 17 and 18 years, the truck will